Hi guys. Okay, so in this video, we are looking at the homework problem 31, which relates to identifying the products, balancing the molecular equation, writing the ionic and the net ionic equation. So here we are given copper chloride and lithium phosphate. So let's identify the products first. So this is a double displacement reaction where copper and chlorine, copper chlorine are going to split and lithium phosphate will split. Lithium and chlorine are going to combine and copper and phosphate are going to combine. Okay, so in this case, we need to write the charges in order to, write the final product. So what is the charge on copper? Copper has +1 charge and +2 charge. But which charge it is right now? Because it's combined with 2 chlorines, therefore, copper will have +2 charge. And chlorines, there are 2 chlorines, but each chlorine is coming from each chlorine is bearing a -1 charge because it's a group 7A. All right, then comes the phosphate. Phosphate is combining. Now, phosphate is a polyatomic ion. It has a -3 charge, so it's standard. On the other hand, lithium is in group 1A, so it will have +1 charge and it's combining with chlorine. Chlorine is in group 7A. So identify the charges. Identify the charges to determine the products. Okay, this is very important. And then just like you do the nomenclature. So what do you get here? We see that this 2 comes here and this 3 is going to come here, the subscript. Similarly, 1 here and 1 here. So what do you get? We get here, in this case, when lithium chloride and copper chloride and lithium phosphate react. So in this case, you're going to form lithium chloride, okay, and copper phosphate. The formula for the copper phosphate is Cu3 brackets PO4 whole twice. So this is Cu3 brackets PO4 whole twice. And the other one is LiCl. Okay, so first step is this, identifying the product. So these are the 2 products. Next is we're going to look at the balancing of the equation. Now balancing, and that is called the molecular equation. Now molecular equation balancing, it's okay to not put charges. Okay, molecular equations. And here, let me write this down in red. So while balancing, it is okay to not put charges because sometimes that gets in the way. It's too many details when you're just learning. Okay, so here let's write this down in balancing. So here we have copper CuCl2 reacting with lithium phosphate Li3PO4, and this gives you LiCl plus Cu3PO4 whole twice. So let's write down the individual atoms. So copper, there's only 1 copper. There are 2 chlorines, right? There are 3 lithiums. There's 1 phosphate. There's 1 lithium. There's 1 chlorine. There are 3 coppers. Let's put this here. 3 coppers. And there are 2 phosphates. Okay, so this is what we have. Next is what is not balanced. Obviously, lithium is not balanced. Coppers are not balanced. Chlorines are not balanced, right? And phosphate is not balanced. So everything is not balanced. So what do we do? If we put lithium chloride, so I'll just leave that on one side, copper, you can start from anywhere, but start from what is like the most pressing. So phosphates are 2 and lithium is 3. So phosphate 2 and coppers are 3. So if we put 3 here, definitely, so that is going to affect the chlorine also. So this is going to 3 times 1 and 3 times 2. So this becomes 6 chlorines. And this gives you 3 coppers. So you balance the coppers, which is fine. But chlorines are 6. So how do you make 6 chlorines? You put 6 here. So 1 times 6 lithiums and 1 times 6 chlorines, and this becomes 6 lithiums and 6 chlorines. So the chlorines are balanced also, but lithiums are now not balanced. Lithium is 3 on one side and it is 6 on the other side. So to make it 6 common multiple, you put 2 here. So this 3 times 2 and 1 times 2, so that 2 applies to both. So this becomes 6 lithiums and it becomes 2 phosphate. So this is balanced now? Yes. If you look at it, phosphates, 2 phosphates here, 2 phosphates here. Next, look at the coppers, 2 coppers here and 2 coppers here. Next, look at the chlorines, 6 chlorines here, 6 chlorines here. 6 chlorines this side, okay? And then the next is the lithium, 6 lithium here and 6 lithium here. So everything is all balanced. So this is a balanced molecular equation, okay? Now we are going to write down the total ionic equation. So total ionic equation, you just have to put the charges, okay? So total ionic equation. Oh, something that I forgot before we do is the solubility. So according to the solubility, right? Let me do this here. Total ionic, we will do this a little bit later. And I need to, let's do this here. Bring this a little bit down. Right here. Okay, so now we have copper chloride. So all chlorides are soluble in water and copper is not an exception. Remember the exceptions to the solubility rule. Exceptions in aqueous solubility. Solubility in water is gastrobar in the mole. Gastrobar in the mole, which means that calcium, strontium, barium, these 3 guys are in the bar, gastrobar. And where is that gastrobar? It's in the mole, where you will also see mercury mole. And that mole is mercury, mole, silver, and lead. You're also going to find these. So these guys have trouble mixing with water, like they'll have partial solubility and so forth. So gastrobar in mole. So just don't forget this solubility, okay? Solubility rules, very important. You should memorize them also, okay? But these are the exceptions. So we see that lead is, of course, the copper and lithium and all these don't fall in the exceptions. So this is soluble. So if it is soluble in water, what do you write? Aqueous, okay? Lithium phosphate. Now all phosphates are insoluble except group 1A and ammonium, and lithium falls in the group 1A category. So this is aqueous. Okay. Next comes the lithium chloride. Anytime group 1A connects with anything, it makes it soluble, and all chlorides are soluble. So with group 1A, it is soluble. So this is aqueous. Phosphates, copper phosphate, all phosphates are insoluble except group 1A and ammonium. So ammonium, copper is not ammonium and copper is not group 1A. So therefore, this is going to be a solid. Okay. Now, do not ionize solids, anything that is solids. Okay. Solid, and then also liquid. So liquid also, and gases also. Okay. So that's one piece right here. Okay, let me make this small because otherwise this gets cut. Okay, here. All right. So now we will have to write down the total ionic equation. Total ionic equation. Ionic equation. Okay, how do we do this? Total ionic equation here is, okay, there are 3 coppers and they are aqueous, and now charge. What is the charge on copper? +2, because it's connected with, remember, CuCl2, +2 charge, plus, and we already discussed all this earlier also. So, and then comes the chlorine. There are 3 coppers and there are 6 chlorines. So basically, whatever you did in the molecular equation, you just have to write this here. 6 chlorines are also, or chlorides are also soluble. Next comes the 6 lithiums. 6 lithiums plus 1 charge. Okay. Put here. 6 lithiums plus 1 charge aqueous plus 2 phosphates. 2 phosphates, PO4 minus 3 charge each aqueous. Okay, this gives you 6 lithium plus 1 charge aqueous and 6 chloride ions aqueous plus the copper phosphate remains as it is. So Cu3PO4 whole twice. So this one is not going to ionize. Okay, this will remain as a solid. So now these do not ionize, as I said. Let me bring this down here a little bit this side. Okay, and change this copper phosphate, write down a little bit cleanly. So Cu3PO4 whole twice, and this is solid. Okay, so this piece is not going to ionize. Okay, now don't break it up into ions. Now, what are we going to write down in the net ionic equation? Net ionic equation. Net ionic equation, you write down all the ions that show change of state. Change of state. So which ones are showing the change of state? Now let's look at it here. So we see that copper is aqueous here, but copper is in a solid form here. Phosphate is aqueous here, phosphate is in a solid form here. Okay, so these are the ones that are showing the change of state. But lithium is liquid here, aqueous here on one side, and lithium is aqueous on the other side, and it's the same number of ions. Chlorides aqueous on liquid on one side, aqueous soluble in water on one side, and aqueous on the other side, so soluble. So these are the spectator ions, and actually the net ionic equation is really between 3 copper ions plus 2 charge each aqueous, plus you have 2 phosphates PO4 minus 3 charge aqueous, and this gives you Cu3 brackets PO4 whole twice, and this is solid. Okay, now what are the spectator ions? Spectator ions are 6 chlorides and 6 lithium ions. So these are the spectator ions, means they remain soluble, aqueous on both the sides. All right, so this is how you determine the net ionic equation. All right, guys, so it comes with practice. There's a lot of details in here, right? And they come with practice. All right, thank you.